Last session today of Code with Claude. I hope you've all had a fantastic day so far. My name is Margot van Laar. I am an applied AI engineer at Anthropic here in London. And this afternoon, we're going to be talking about the prompting playbook. And prompting is arguably one of the first skills, if not the first skill, that we had to learn as engineers when we first started to work with LLMs. And even now, it continues to be one of the most critical skills to building effective AI systems. So today, we're going to discuss some best practices in the context of two practical scenarios that you're probably encountering at work. The first is where you have an existing prompt in production that you've been maintaining for some time, and possibly you're migrating it to a new model or making a change to the architecture, and for some reason, it's no longer working as well. The second scenario is where we're building an entirely new agentic use case from the ground up, and we need to build the prompt from 0 to 1. Now, in order to illustrate these best practices, I don't just want to give you a list of do's and don'ts. I want to walk through a practical example that's been inspired by real prompts that I've seen some of our customers work with who are building on Claude. So the prompt that we'll look at today is a miniaturized example. The prompts that you're working with are probably a lot longer and more complex than the one we'll see today, but it's representative of some common problems that you might encounter when maintaining a prompt. So imagine that we have a prompt that multiple people have been collaborating on, contributing to. There's no clear owner. It covers a lot of different areas like policy, like tone, processes. We have some patches for kind of previous models that we've migrated to, all mixed together. It's built up and it's complex. And when we're migrating to a new model, we're finding that suddenly a lot of our test cases are no longer working as well as we expected. So what's actually going on here? Well, in order to start unpacking that question, we need a starting point, and that starting point is evaluations. We need evaluations to provide that rigor to understand whether a change to our prompt is actually correlating to an improvement in its performance. And we have different models which have different capabilities and different behaviors. And when you migrate to a different model, it could be that your system is no longer working as well for two reasons. First of all, if the new model might be capable, but it's behaving differently, and therefore we can tune our prompting to fix that behavior. The second case is where actually the model that we're changing to isn't as capable, and no amount of prompting is going to fix that. So we need to have an eval suite to act as a way of testing that regression so that we can apply our prompting best practices to that. So in the example that we're going to be looking at today, as I said, it's going to be a miniaturized example. We'll have 5 test cases in our eval. In reality, you'll have a lot more test cases in your eval suite, but the key thing here is that it's representative of 3 key cases that we need to cover. Those 3 key cases include having a control case, which is a case which should always pass. It's something that we know the model handles well. It's unambiguous. The second is edge cases, and these are cases where we've seen the model fail before. And by including instructions into the prompt, we're making sure that same behavior doesn't slip through again in the future. And finally, and critically, we need to make sure that the model has a good understanding of the extent of its capabilities, where it should be handing off to a human, or where actually maybe it should be point blank refusing to answer a request. So in the example that we're going to be looking at today, we'll be using a prompt for a customer support bot for a telco company called Meridian Mobile. And these are the 5 test cases that we are going to be looking at today. We have a simple control case looking at, what's the data limit in the basic plan. We're also looking at edge cases, such as its ability to do calculations, such as calculating proration bills. If I switch my bill halfway through the month, or if I switch my plan halfway through the month, what will my bill look like? We want to check that it's accurately addressing key questions which are covered by our policy. We need to make sure that it's escalating to a human whenever there is a billing error. And finally, we want to make sure that our model isn't withholding any information that it has access to, which it should be handing over to the customer. So what we're going to do in this process is we'll take our prompt and we'll run it on our V0 of the eval. And we'll see what our failure modes are and systematically target those failure modes one at a time to see if we can resolve those failure modes by prompting. And along the way, we'll learn a little bit more about the kind of anti-patterns and traps to avoid. And this is representative of how we would apply these best prompting techniques in practice, right? We are rarely writing a prompt from scratch. We're often debugging an existing prompt. And best practice before we start targeting those failure modes specifically is to kind of apply our general prompting 101 best practices, applying general hygiene to clean up before we do the eval run. So let's have a little look at the example that we're going to be using. So what we're looking at here, first of all, before we look at the prompt, is just this vibe-coded web app that I've made for the presentation today so that we can look at how we're iterating on the prompt together. In this page here, I can easily run my evals on all 5 test cases and inspect the results in a little bit more detail. So before we have a look at the prompt, I'm just going to run the evals in the background. This is a pretty good first pass at a prompt. When we look at this, we've defined the bot's role at the top. When we scroll down, we've given it some data. We've given it some information on how to reason over the answers that it should be giving to the customer. It's giving some critical instructions around the tone it should use, how to do calculations, etc. And then finally, we're passing in our customer account context and our user message. So let's have a look at how our first pass at the evals did. So we can see, as we expect, our control case, all of our test cases have passed. This is what we expect for this unambiguous test case. But it's performing pretty poorly in these other areas. Now, before we zoom in on those specific failure modes here, let's do some general cleanup of our prompt. So as we mentioned, when we look through this prompt, there's a couple oddities here already. So for example, the first one is we're telling the bot that it's a human, which just isn't true, right? We can see as we scroll down, there's clearly some information here that has been copied directly from a website. So the key giveaway here is a reference to a hero image. There's even some references to cookies at the bottom. So we need to remove a bit of redundant information. When we look at the instructions here, they're all grouped into one big paragraph. So we've got some reasoning here, we've got instructions about the role, some critical instructions as well, without a real way of unpacking policy from guidelines, from tone, etc. So let me just... I've preempted some changes we want to make to this prompt, and this is just a diff view of some of those changes. So what we've done is, first of all, added some structure. So you can see that we've added XML tags here to define the role, to separate general guidelines, to separate policy, to separate tone of voice, etc. So if we run that eval then on this new updated prompt, we should hopefully see an improvement in the output as is. So we can see just by clearing up the prompt, we've already improved the model's performance on this prepaid scenario. There's an interesting regression there in that fifth hotspot case, and I don't want to worry too much about that now. There's going to be some natural level of variance in the different runs of the eval, and we'll come back to that case specifically to see if we can make the prompt consistently better in that area. So what did we learn from this then? Simply clearing up the prompt with a better structure, with a better role description, has improved the performance. And this is a best practice that you can return to at any stage of writing and maintaining your prompts, especially as your prompts get more detailed and more complex. A general rule of thumb that I like to follow is if you're reading a prompt and you can't tell guidelines from policy, from data, most likely the model isn't able to either. So before looking at some of those cases in more detail, there's a little bit more general cleanup we can do, specifically here looking at creating an output contract. This is a key best practice to follow if you're struggling with your output format consistency. Now, in this case, we have a customer support bot. We want it to reply in a conversational tone, so it's unlikely to be a big issue in this case, but it's something to bear in mind if you're dealing with more complex output structures like nested JSONs, for example. So again, if we go back to the prompt and see what fixes we can apply here, first of all, we've added a section at the end where we've defined an output format for the model, telling it to use XML tags to output the response. But the prompt is not always the most effective way of handling issues. We can also change things in the harness to ensure consistency to a higher degree. So what we've added here to the API call is a stop sequence, which is going to detect that closing XML tag and tell the model to stop generating a response at that point. Now, when I run the eval here, I don't necessarily expect to see any clear improvement in performance, but it's a general best practice that we should be following, and as I said, is something that we should remember, in particular when we have more complex output schemas. One thing to point out here as well, if you do have a more complex output schema, something like structured outputs can be incredibly helpful to ensure that consistency in a more programmatic way. Okay, so after the cleanup then, we can see that we now have 2 test cases which are consistently passing, but we have 3 key failure modes: the proration, the billing error, and the hotspot. So let's isolate these one by one to iterate on the prompt and see the effect of that. First of all, then, the hotspot question. So the question is, how much hotspot data is on my unlimited plan? What we expect the model to do is state directly the amount of hotspot data that the customer has. And the reason this is a slightly complex case is because the customer test case that we're dealing with is on a legacy plan. So actually, the current policy doesn't apply to them. So if we see what's going on in the actual test case here, the customer data which we're feeding to the prompt includes the amount of hotspot data that customer has. They have 5 gigabytes, right? But they also have a grandfathered plan. So what we're seeing the model is actually telling the customer is the general, the unlimited plan includes 4 gigabytes, but since you're on a legacy plan, you should go check this out yourself. So let's have a look at the prompt then to see why the model is deflecting this question to the customer account URL rather than actually giving the information itself. Now, if we read this prompt, originally it said, we changed our plans recently, and the policy doc shows the current plan data and customers on grandfather's plan have different rates. Never give a customer the wrong plan details. Instead, point them to the URL. So it's clear that this instruction, this latter one, never give customer the wrong information, is the instruction that the bot has been optimizing for. And you might recognize this as being very similar to a patch that you might have introduced in a previous model that you were using to avoid, where the model was giving the customer the wrong information about their plan. Now, as our models have evolved, they've gotten much better at instruction following. So it's likely that instructions like these have now become redundant and are actually being overfitted to. So what we're going to tell the model instead is give this balanced view where it says, customers on grandfather's plan have different allowances, but it's captured in the customer information that's given, and that is the accurate source of truth. So running the eval here, we should hopefully be addressing all of the test cases for the hotspot case. Now, I am running this live, so there could be some variability here, but we see here that now clearly all of our test cases are passing. So what did we learn from this? Well, we worry a lot about hallucinations or the invention of facts and numbers, but actually the opposite can also happen. The model can withhold information that it actually has access to. Now, we saw here that this is likely a result of a patch that we introduced for a previous model, and a best practice that we could follow here is actually using version control, where wherever we are making defensive changes in the prompt, we are tracking the reason why we've introduced these. Sometimes they're necessary, but in the future, these kind of changes can produce unwanted effects so that we can backtrack on them. So the next failing test case then is this proration calculation, where a customer asks, what if I upgrade to the 30 gigabyte plan? What will my next bill be? And what we want the model to do is to perform some calculation and return exactly what their next bill would be, rather than giving some sort of vague output, which is what we can see it's doing right now. If we look at what the model is returning, it's clearly reasoning through it. It's doing a little bit of mental math here and there, but it's not really giving the customer a concrete answer, and I wouldn't rely on this as being able to accurately give the customer a response. So if we look at the prompt then to see how we can fix this, in the original prompt, we can see that all the instructions that were given to it is telling it, don't ever give a customer a vague answer. Critical, always calculate any prorated amounts correctly. Now, telling the model to do a good job isn't particularly helpful when we don't give the model the capability to actually do a good job. We want to avoid the model doing mental math. So what we're going to introduce is give the model a tool. So we're saying in the prompt, whenever you're doing any calculations, please use the calculate proration tool to do so. In order to introduce that tool, we need to introduce it into the API to tell the model you have access to this tool. We need to define the tool schema, which tells the model what this tool does and when to use it. And then finally, we need to actually implement the tool, which is the maths behind how it should be doing that calculation. So running that eval then for another pass. We can see that all the test cases are now passing. It's clearly done the maths using the tool in the background and returning the correct response. So the key lesson to take away here is instructions don't add capability. Telling the model it's critical to do a calculation right doesn't make it better at mental math. So the correct approach was to give it a tool, overall giving it the ability to reason over harder problems and using tools to actually execute them reliably. So now we have one final failing test case which we need to address, which is this billing error here. In this scenario, there is a billing conflict, and what we really want is the agent to escalate this to a human. And what we're seeing it doing instead is it's trying to explain to the customer what the reason behind it might be, and it's trying to kind of diagnose the problem itself. So in order to fix this behavior, let's again have a look what it was told in the prompt. We see in the initial instructions it was giving, it says, avoid escalating or transferring to a care specialist unless absolutely necessary, as it cost approximately $8 and it counts against our team's fast contract resolution. Now, this is only giving one side of the story, right? We're telling it what the cost is to escalating, but not the benefit, which means it's going to overfit again to not escalating this scenario. And second of all, we've got this clear conflict between what we've defined in the eval in terms of what we want the model to do this escalation versus what we're actually telling it to do. And the fix that's relevant here is to give it both sides of the story by saying it costs $8 to escalate a case, but actually, if you get this wrong, then it's going to cost you a refund as well as customer trust. Again, here we observed how the model optimizes for a goal, and this kind of instruction is a common instruction to give. It's quite similar to the one we saw earlier, where we didn't want it to overfit to a certain type of behavior. But it's the kind of instruction that can be followed quite differently by different generations of models. And specifically, as models become more intelligent, we need to remember to state both sides of the trade-offs, because our models are becoming better themselves at making those trade-offs themselves. So if we just go back to our eval then and run our final test case, we should see that all of our evals are now passing correctly. So overall, we looked at applying general hygiene principles, how that can provide an initial uplift to the prompt, making sure we're removing any redundant instructions which were initially intended as patches for previous models' behavior, making sure we're giving it tools to do certain tasks reliably. Now, there's one other scenario that we introduced at the start, which is one that you might also encounter in your work, which is where we're building a new agent from scratch. And the example that we'll look at here is an agent whose purpose it is to create a week-long retail staff schedule based on employee availability and other constraints. And when we're building a new agent from scratch, we need to consider not just the prompt, but also the model that we're using and the harness that we're using. So in this next example, we're going to compare a number of approaches to explore the impact of those three different areas. So again, I've just vibe-coded up this web app so that we can walk through this problem in this demo. Here I've just laid out what the problem is that we're addressing. We have our 8 employees. On the right, we have this schedule that we need to staff with the headcount, and we have our constraints that must be satisfied in every scenario. Now, because we have these hard rules, rather than using an LLM judge like we did in the previous case to do the grading, we can actually use just a Python function which programmatically checks for every schedule that's generated how many violations were made. So to begin with, we want to start simple. We're going to use a simple prompt. We're going to use the bare bones that we think we'll need with a model, Sonnet 4.6, to see how it performs and how we're going to hill climb against that. So here is our baseline prompt. We've already applied some of that general hygiene and those best practices that we saw earlier on, using XML tags to structure the prompt. We've given it an output format as well. Now that we're giving a schedule, we're asking it to output a JSON, which, if we don't give that output structure, might lead to parsing errors downstream. When we run the simple model on a first iteration of the evals, all cases fail. Now, just what we're looking at here is in our test set, we're essentially repeating, we're doing 5 trials here, and these numbers are showing how many violations were made in each trial. In the outputs, we can see that it's made a decent attempt at reasoning through the problem, but it's burning a lot of tokens, and it's clearly not checking its work as it's not getting to the right impact. So let's try a larger model, a model which we know is better at reasoning. So we're going to run it through Opus 4.7 instead, keeping everything else the same. Now, interestingly, whilst all test cases are still failing, you can see that the overall number of violations that Opus has made has reduced significantly from Sonnet 4.6. So we're possibly onto something here, right? This isn't good enough to ship because it's still failing, but clearly giving it more reasoning capability is helping drive it towards a better result. So what we're going to try next is using Opus with adaptive thinking instead. So it can decide for itself how much thinking it needs, how much reasoning it needs to use to solve this issue. So no change to the prompt, really just a change to the API here. So this now seems to reliably generate compliance schedules, but it requires a lot more tokens. We're tripling, essentially, in the number of tokens that we're using here, and we're tripling the latency. So we want to try and see if we can optimize that cost-latency trade-off a little bit more. This is latency 100 seconds. Obviously, I'm running this one async for the purposes of time. Opus 4.7 hasn't magically gotten much faster since the last time you used it. So let's see if we can optimize a little bit more for the token latency trade-off. What we haven't tried yet is using Sonnet 4.6, so a smaller model, but with a better prompt. We looked a lot at the prompt optimization in that last section. So I've added a couple details to the prompt here. We're in particular how to reason through this problem, and most critically, telling it to check its work before outputting it. So when I ran that eval, we see that it passes in 2 out of the 5 cases. Now, the failure modes that we're seeing is actually not violations of the scheduling requirements, but the model hasn't been able to finish the tasks within the output limit that we set. So whilst we could increase the max tokens that this model is able to use to get all 5 test cases passing, we see here that we're using even more tokens, and this run has an even higher latency. So this is probably not the route that we want to go down. Now, as a final pass then, we want to look at doing this a little bit more agentically. So we're going to use this generate, evaluate, repair loop, where essentially the generator now creates a first draft of the schedule. And then we have a separate prompt which reports any specific violations that it made. So not programmatically checking it, but checking it with an LLM. So we're checking for every rule, and we're providing evidence of every violation. And we then have a third repair prompt which receives any violations that were made and tries to make targeted fixes to it. So we have 3 very simple prompts, but they're now running independently rather than trying to do everything in one large prompt. So we can see in this case our agentic approach has solved all of our test cases with a much lower number of tokens and with a lower latency than trying Sonnet 4.6 with a better prompt. So going forward, it seems like there's 2 appropriate approaches to take here. Using Opus 4.7 with adaptive thinking, or using this agentic loop. Now, moving forward, we'd probably want to do a little bit more optimization on this loop to try and get it to be more efficient. But there's one key benefit as well from using this generate, evaluate, repair loop. And that is that you can put in soft requirements at runtime. So in the evaluation prompt, we can say, Harry doesn't like working with Sally, so as much as possible, try and separate them from working together. Or we need a third shift on Wednesday, for example. So it means that you're not having to make changes to the Python function, which is doing the evaluation in the back end every time to satisfy for any soft constraints, which might depend just on a case-by-case basis. So to wrap up then, pulling all of those learnings together, what did we see? Well, we looked at 2 scenarios which I as an engineer see most in my day-to-day, which is where we're maintaining a prompt, we're migrating to a new model which has some different behaviors, and building a new use case from scratch. We saw that general hygiene principles, following those can immediately uplift the performance against a set of evals, and that we need those evals to be able to rigorously see any impacts of changing our prompt on the output. Then we saw this process of targeting failure modes one by one, adding structure, avoiding long ban lists, etc., were all things that helped push our model to the correct behavior. And then finally, with our new agentic bot that we were building, we saw the impact of splitting into 3 separate prompt systems. So rather than using one prompt to address everything, we're actually isolating different tasks where it's easy and repeatable to separate out the steps that it needs to take every time. Thank you so much for attending this afternoon. I hope you have a fantastic rest of your day.
Tell it the situation and be like, hey, can you fix this for me? It's incredible. Now, let's talk about best practices. And the first one is not going to be a surprise, but the first one is use Claude.md files. So remember that Claude Code, like I said, is an agent, and it has some tools. It has some lightweight instructions in the prompt, but it doesn't really have memory. And so the main way we share state across kind of sessions or across our team when we fire up Claude Code in the same code base over and over again is this Claude.md file. So when we start Claude, what happens is if there's this Claude.md file in the working directory, it's just plopped into context. It's plopped into the prompt. And basically what it says is, hey, Claude, by the way, these are important instructions the developer left for you. Be sure to pay close attention to this. And there's various places you can put the Claude.md file. You can put it in a project and check it in so all your teammates share it. You could put one in your home directory if there's things you just want Claude to always know about, regardless of what you're working on. And the things you put in here are things like, hey, by the way, maybe this is how you run the unit tests. Or just so you know, to make kind of your searching and life easier, here's just like an overview of kind of how this project is laid out, where the tests live, what different modules are, things like that. Or here's our style guide, all sorts of things like that to just make Claude's life a bit easier. And you can build these things up over time. The other thing you can do, which is important, is permission management. When you're running Claude Code, there's all sorts of different kind of permission things flying by. Kind of out of the box, what happens when you start our tool is for read actions. If Claude is searching or reading, we just let it go. But once it starts writing or running bash commands or doing things that could change stuff on your machine potentially, that's when we kick in this UI and it says something like, yes, always allow this, or no, I want to do something else. And using that permission management and being smart about it can help you work faster. So there's something called auto accept mode, where if you're working with Claude Code and you press Shift Tab, Claude will just start working. There's things you can do, like you can configure Claude in the settings where specific commands, like on bash, like if you just are tired of saying yes, run npm run test, you can just always approve that. So fiddling with your permission management is a great way to kind of speed up your workflow. Integration setup. So one thing that is going to help you get the most out of Claude Code is remember that it's great at the terminal. And if there's applications that you use which have kind of a way to access them through CLI, and GitHub is a great example of that. They have a powerful tool called GH. You can basically give more work to Claude Code. And you can do that either by just installing more CLI tools, or you can attach more MCP servers. I would say, just through experience, that if you're using something like a CLI tool that's well known and well documented, and you're trying to choose between the CLI tool and just installing it on your machine and grabbing an MCP server, I would recommend using the CLI tool. And then also, if you internally have your own tools, at Anthropic, we have something called Coup that does a whole bunch of stuff for us. You can also tell Claude about that, and that's the sort of thing you'd put in Claude.md. And then context management. So remember that Claude is an agent, and when it's what it does, it calls these tools, and the context builds up and up over time. And at least for Anthropic, our models have a context window of 200,000 tokens, and you can max this thing out. So you kind of have two options when you're in a long session with Claude and you're working and you're going back and forth. You'll see in the bottom right, you'll start to get this little warning that'll say, hey, you're starting to fill up the context window. And kind of depending on what's going on, you have two options. You can run /clear and just start over, and that clears everything out, except for instance, Claude.md. Or you can run /compact, and what'll happen is basically it's like a user message is inserted, and it just says something like, hey, I need to go summarize everything we've been up to. I'm going to give this to another developer, and they're going to pick up where I left off. And then that summary is what kind of seeds the next session, and you can go from there. We spend a lot of time tuning this kind of compact functionality so that as you max out the context window and then run compact, you can start back over and keep going. Efficient workflows. What can you do with Claude Code? And how do you get the most about it? So using planning and to-dos. I talked a little bit about this before. But one of the best things you can do is when you open up Claude Code, instead of saying, hey, I need you to fix this bug, you can say, hey, I have this bug. Can you search around, figure out what's causing it, and just tell me a plan how we're going to fix it. And this can save you a lot of time because you can verify, you can read Claude's plan, and you can verify what it's going to do. And then the other thing that we have is we have this to-do list feature. So often when Claude's working on a big task, it'll create a to-do list. And if you're kind of paying attention, you can kind of watch this to-do list. And if you see anything kind of weirder in there or something that doesn't make sense, that's when you can press escape and say, hey, Claude, let's change the to-do list. I think you're on the wrong path. Smart vibe coding. So it's very tempting and it's very powerful to just let Claude work and press enter and see what happens at the end. I think there's a few things that can help make this better, and there's, I think, a talk later today about just this for 30 minutes. But doing things like having test-driven development, having Claude make small changes, run the tests, make sure they pass, always having Claude do things like check the TypeScript and the linting, and then commit regularly so that if it's kind of going off the rails, you can always fall back and try again. You can use screenshots to guide and debug. So Claude is built on top of our models, which are multimodal. You can always just grab a screenshot, paste it in, or if you have a file somewhere that's an image, you can just say, hey, Claude, look at this mock.png, and then build the website for me, or whatever. And then advanced techniques. So as you're getting used to using Claude, what are some things you can think about to kind of push things to the next level? And one of the things we see, both internally and with customers, is when you've started to use this tool for a while, it's going to be very tempting to use multiple Claudes at once. And so I know people at Anthropic and a few customers that run 4 Claudes at the same time. There's various ways to do this. You can have it in tmux or just different tabs, all sorts of crazy things. So I would challenge you to try getting multiple Claudes running at once and kind of be orchestrating all these things. It's quite fun. I can only do 2, but I know people that do 4. Use escape. So escape is your best friend. While Claude is working, you can kind of keep an eye on what it's up to, and you can press escape to stop it and interject and say, hey, I think you're going on the wrong path, or I want you to do something else. Knowing when the right time to press escape is versus just letting Claude figure it out is key to getting the most out of the tool. And there's a hidden feature, not too many people know about it, but if you press escape twice, you can actually jump back in your conversation. You can go back and you can kind of reset. Tool expansion and MCP. So this is taking it to the next level. If you feel like with Bash and with the tools that Claude has that it still can't do something, this is when you should start looking at MCP servers. And then headless automation. I think this is a thing we're most excited about, but also we are still trying to wrap our heads around internally, which is how can we use Claude programmatically? We have that in GitHub Actions. We want to figure out other creative places we can start using it. And I would challenge you all to do the same. So with that said, I'm going to jump over to my computer because there's one other best practice, which is it's always good to stay on top of everything that's new. So we're shipping super fast. I'm just going to go over a few things that are new as of today. One thing is when you're in Claude now and you fire it up, you can do /model. You can see what model you're running on. I'm on default, which happens to be Sonnet. We can jump over to Opus. You can do the same thing in /config. Switch it here. So that's new. Make sure you're running the model that works for you. There's another thing that's new about these models, which is you can say something like, can you figure out what's in this project? And for a while, we've had this like think hard or extended thinking. Now, this is great, but with our past models, we wouldn't let our model think between tool calls, and that's probably when the thinking matters most. So starting with Claude 4, our models now think between tool calls, and we can watch this happen. So we have Claude in this project. There's a few different files in here, and I'm just going to tell it to think hard and figure out what's in this project. And we can watch Claude start to work. And so the way you know you triggered thinking is you'll see kind of this lighter gray text, and then it'll call some file, it'll call some tools, it'll read some stuff, and then we see some more thinking. And this is awesome. So I encourage you when you're working on tasks and solving bugs, throw a think hard in there. And then the other thing, and you know what? We'll just throw it up real quick, is I have this in VS Code, but of course this is in JetBrains as well. But we have these new great integrations with VS Code and JetBrains. We can do things like Claude's going to know what file I'm in, what file am I in. That is not what I meant to say, but Claude's going to figure it out. And you can do things like this. So these are the sort of things I would encourage you to stay on top of. We have a public kind of GitHub project called Claude Code under Anthropic. You can post issues there, but we also post our changelog there. And so I check this once a week and make sure that I'm on top of all the new stuff we're shipping, because even I can't keep up with it. So with that said, we have like 4 minutes left. I'm happy to answer questions about anything Claude Code related. We have it here. I can live demo some stuff if you're interested. Let's do a few.
Let's do him first, and then you. Okay.
Thanks. Real quick, this might be obvious, but multiple Claude.md files in a project, I presume that's possible and it just figures it out, or no?
So there's a few options. Of course, like in the same directory, you couldn't. But you could have one here and one in a subdirectory. And I think we changed this so that all the subdirectory ones aren't read in, because like Anthropic, we have a monorepo, and people would open it at the top and blow up their context with all the Claude MDs. So we encourage Claude, when it's searching around and it discovers Claude.md files in child directories that are relevant, to be sure to read them. But by default, it just reads the Claude.md file in the current working directory when you fire it up. And then also you can set one in like your home directory. There are things you can do though. We have this new thing, like in your Claude.md, you can start referencing other files. So you could, for instance, do something like this with an @ sign. If you have other Claude.md files that you just kind of know you always want to read in, to do something like that.
Hi. Okay. I have not had luck getting Claude to respect my Claude MD. Like, there's one thing particular.
Yes.
Where I'll ask it to refactor something, and then it will leave inline comments explaining the what
Yes.
of it is, and it's like something that's extremely
Yes.
obvious. And so I'll tell it like, go and remove any inline comments that describe the what of what's happening, and then it will remove it, and then immediately do it again in like the same pass. So do you have any strategies for dealing with that?
So there's kind of two things that fix that. So that was actually kind of a model problem. There's nothing in the prompt. We have actually a lot in the prompts for 3.7 that said, whoa, do not leave comments. And despite that, the model just loves to leave comments. So it doesn't surprise me that your Claude.md didn't help much either. We already did a lot. I did a lot of work to try to tamp it down from what happens out of the box. So we mostly fixed that in Claude 4. Now there might be some new weird behavior quirks, but the other thing we made better in Claude 4 is it's just better at following instructions. And we've gotten a lot of feedback from early testers that all of a sudden, whoa, my Claude.md is being followed way more closely. And it might be a good chance to go look in your Claude.md and decide, do I still need this stuff? Maybe I can take some of it out. Maybe I need to add a few new things. So moving over to the new models might be a good time to take another look at what's in there and see what you need and what maybe can go.
For the record, I'm trying to think of something that you might not have thought of.
Yes.
When doing multi-agent execution and parallelization, can you make it so that for 4 agents, say, agents 2 and 3 use the context from agent 1, maybe agent 4 uses the context from agent 2 at a certain point?
Yeah.
Yeah, etc.
That's interesting. We're trying to, so kind of like I said at the beginning, we're trying to do the simple thing that works, which is just one agent that's great at coding and does everything. I think we want to figure that out. Probably what's going to happen is if you wanted to do that, you would ask all your agents to probably like write to a shared markdown file or something like that, so they can all kind of like check in and communicate. Sometimes like I'll be working with Claude.md or Claude, and I'll just say like, hey, I need you to write some stuff in like ticket.md for another developer, and then I'll fire up another Claude code and I'll be like, hey, read ticket.md, like another developer left this note for you, like this is what you're going to work on. So I'd think about trying to write that state to a file and then just kind of like count on the model's ability to just like read files and make sense of them. It's probably the best you can do today, and maybe we'll figure out clever ways to expose that in the product as something more native. Cool. All right. And with that said, I have some rare Claude Code stickers that I found in my backpack, so come find me. I'll be hanging out over there or something. Happy to share them. Thank you.
Can everyone hear me? Thumbs up, all good? All right. Everyone, I hope that you have had a fantastic day at Code with Claude London so far today. My name is Will. I'm on our engineering team at Anthropic. I sit on a team called Applied AI. What that means is I essentially split my time between internal engineering work and time spent building agents with customers. So folks, imagine that you built and shipped an agent to solve a problem. I'm sure that's something that a lot of the folks in this room have actually done. And imagine that this agent worked fantastic, right? But it worked so well that a few weeks after shipping, you were asked to add some additional capability to the agent. A few weeks after that, you received more business requirements and you added additional capability. This pattern continued and continued until, before you know it, your system prompt had grown to become several hundred lines long. You have dozens of tools and sub-agents that exist for your agent. And because of the complexity, you've started to see regressions in the areas that your agent was previously accelerating in. So if this is you, you're not alone. We see this type of scenario happen pretty commonly with customers and actually with ourselves included in that. So within this workshop, we are going to simulate an agent that has essentially grown to a complexity where we start to see degradation in its performance. We're then going to walk through some of the decisions that we as engineers and architects make in order to improve the design of our agent to restore the performance that we expect with the additional capability. Specifically, we're going to make some decisions around tools and skills and sub-agents. As we modernize the stack of our agent, we want to make sure that we're using the right agentic primitives at the right time. So when do you use a tool, when do you use a skill, and when do you use a sub-agent? We're going to talk through all of that in this session. As I mentioned, folks, this session will be hands-on. So let's go ahead and get started. I first want to walk you through our problem statement in our agent. So for the purposes of this session, we're going to be focusing on an agent called Stock Pilot. This is an inventory management agent that was designed by and for a mid-size retailer. The agent that you see on the screen can do several things. It can flag low levels of stock. It can forecast demand. It can pick suppliers. It can file POs. And ultimately, it can write weekly reports for the employees of this retailer. Now, none of these capabilities are particularly complex on their own, but again, the issue is that we've essentially bolted capabilities onto our agent over time without modernizing our architecture. This complexity has started to cause some problems. Let's take a look at the actual architecture today of the agent. Folks, today the agent is facilitated by a single orchestrator. So you see the Stock Pilot orchestrator sitting at the top of the screen. The agent has a system prompt, as I mentioned, that's grown to be about 400 lines long. It has 12 different tools. 3 of those tools happen to be wrappers around sub-agents with completely isolated context windows. So if you have the repo pulled up, which we'll go into more detail in just a bit, there's an agent that's under a folder called Before, which essentially walks through this agent exactly. So again, orchestrator, long system prompt, a lot of tools. We have a lot of sub-agents. The result of this is that our evals have started to dip. So let's imagine how we got here for a moment. Again, like we built that agent up front to solve a really specific problem. We received business requirements to say add maybe some forecasting capability to our inventory management agent. So what we decided to do was essentially just spin up a forecaster as a sub-agent. Again, later on, we received more requirements to add report writing capability to our agent. So we decided to add another sub-agent for that report writing capability. Again, our eval started to dip over time because we added more and more complexity while just bolting this capability on. So let's take just a little bit of time and talk about evals specifically. For this agent, folks, we have 12 different eval tasks across 5 different types of graders. So my colleague gave a talk on evals shortly before this. Evals will have a component within this workshop, but it won't be the main focus. I'll give you a quick summary of the tactical evals that we're using for this agent. On the left side of the screen, you see some IDs. You see several evals that start with the letter R. This stands for regression. These are more realistic, single-turn tasks that we grade the model's capability on. So imagine I give the model a task. The model comprehends that task within the agent, calls some tools, and then provides a response back to me. We're essentially evaluating that response. We also have some more complex tasks that we're grading the model on. So you see those F IDs, the IDs that start with F on the left side of the screen. That stands for failure mode. In this case, we're evaluating the model over a more complicated multi-turn task that we're grading. Now, again, I won't go into evals too specifically. We have a number of different types of graders that are both deterministic and non-deterministic. Right? When I talk about deterministic evals, we're grading things like turn count and like latency and like the number of tokens that are used as our agent is completing a particular task, and we're tracking those deterministic metrics over time. We're also using the idea of LLM as a judge to evaluate the non-deterministic characteristics of our agent. So personality and tone and style and output quality, we're using a non-deterministic grader as a part of our eval to evaluate our agent's non-deterministic characteristics. Now, we're going to run the evals for our agent in just a bit, but when you do, you'll find that the agent is struggling a bit. I'll talk about some of these evals in just a little bit more depth. So F1 on the screen, third from the bottom, this is essentially simulating a daily low stock sweep. So again, this is an inventory agent. We're simulating our ability to look through all of our inventory and pull the low levels of stock. This eval, you'll find, will actually fail because the agent is going to do the right thing, but it's going to take a very winding path to do so. So instead of taking the straightest line from point A to point B, the agent is going to take a very inefficient path. It's going to get to the right end, but it's going to fail the eval because it's not at the efficiency that we'd like. F2 on the screen is another eval that you'll see fail. This eval actually evaluates the ordering process under a particular promotion package. This is going to fail because we are using a sub-agent for this particular task. The sub-agent is actually getting the task right, but there's a communication breakdown between our sub-agent and our orchestrator. This is a really common point of failure that we see when customers have really complicated systems with a lot of sub-agents. It's important to get the communication between your sub-agents and your orchestrator just right. In the case of F2, like you see on the screen, this is an eval that's going to fail because we have a breakdown in that communication. The last one that I'll highlight that you'll see fails is R8 on the screen. R8 will essentially check the forecasting during a particular promotion month. This eval is also going to fail because we have 2 different policies that live in very different parts of our system prompt and actually end up contradicting each other. So I mentioned over time our system prompt has grown. We start to have some conflicts and the model gets confused, leading towards a failure for this particular eval. Now, in the repo, you'll see it in the README, when we run these evals, you'll see that they're going to pass up front at about 83%, which is okay, but if you work in the world of manufacturing, that is not okay. 17% failure is a really expensive failure percentage. Now, let's double click on R8 again, just so that we can understand a little bit about what's happening behind the scenes. Again, R8 is where we're essentially calculating the forecast during a particular month with a promotion. And so in on my screen here on the right side, where you see kind of the simulated terminal window, within the first block under the commented text, we can see that the agent pulled the right forecasting baseline and also pulled the right promotion multiplier. So forecasting baseline, 12 units a day, promotion multiplier, 3.1x. This is all correct. But in the calculation part below that, we can see that there was actually some kind of hallucination that happened. Instead of using that 3.1x promo multiplier, the agent actually ended up using 1.35. So something happened along the way. A hint here is that the reason for this is that we have context problems. So this isn't a model problem. It's an issue with the information that we're surrounding the model with. Our system prompt has grown to be really long and is very confusing for the model and has some conflicts in it, which lead to the issue that shows up within this eval. So folks, our objective in this workshop will first be to run our suite of evals. We're going to triage the issues, and we're going to update the design of our agent accordingly. And then we're going to do something that we call internally hill climbing towards eval improvement, right? So we run our evals, we get a baseline. It's going to be about 83%. We're then going to optimize the architecture of our agent, and we're going to continue then running our evals so that we climb on them, hopefully seeing the success percentage improve over time. In this lab, we're also going to start with an agent that is self-created on our messages API. Again, if you have the repo and you click on the before folder, I'll show you this in just a bit. This is an agent that is built from scratch on our messages API. We're going to actually migrate that agent to Claude managed agents. Claude managed agents essentially allows us to offload the messiness that comes with maintaining an agentic harness and scaling agents safely and securely to thousands and tens of thousands of users, right? Like if I want to build my agent locally and run it locally, I can do that pretty quickly and pretty easily. But the moment that I need to take that agent, I need to host it remotely, and I need to allow hundreds and thousands of users to, at the same time, engage with that agent. There's an infrastructure problem, there's a scaling problem, there's memory, there's security, there's so much that I have to account for. So in order to offload that, so I can just worry about the architecture of my agent itself and make decisions around tools, skills, and subagents, I'm going to offload everything else to Claude managed agents. So again, to break that down just a bit, there's been a few talks on CMA so far today, but this is really where we're able to separate the agent from the session details, from the sandboxed environment where tool calls are actually happening. Again, this allows us to offload particular parts of the stack to then only worry about the design of our agent itself. All right, I mentioned that we're going to get hands-on in this workshop. We are going to go ahead and do that right now. Now, what you see on the screen here is the workshop URL as well. If you haven't had a chance to grab it, feel free to go ahead and do so. This is where we're keeping all of the different workshops throughout Code with Claude within London, so you can go back and revisit them if helpful. Within this workshop, we're going to be working on agent decomposition. So that's going to be the name of the folder that we're actually going to be working within. Great. Let me jump forward here. Perfect. So the first thing that we're going to do as a part of this workshop is we're first going to get a baseline. So when you open up that link, you'll first clone the repo. So we're going to clone the repo locally. We have a UV project that's set up, so we're going to run UV sync in order to make sure that we have all of our packages and our dependencies to be able to invoke the Anthropic SDK and then eventually deploy our agent to Claude managed agents. So we can run UV sync to do that. I mentioned previously that we're going to need an API key for this workshop as well. So using those credits that you got at the start of this session, you can go to your Claude console account and create an API key. If you copy the env example, you'll just have to manually copy your API key into the env file that's created for you. Now, all the 12 evals that I previously walked you through, we have all of those set up already. So in order to get a baseline and run those evals, you have to run uv run evals -- agent before. This is all in the README, but if you just run that command, you will be able to actually go about running your evals. Now, in terms of our building here, we're going to take a number of steps to actually go about running our evals, using Claude Code to triage the results of them, and then climbing accordingly on our agent. So we're first going to take a look at the system prompt that we have for our agent itself. So I mentioned earlier that our system prompt is currently sitting at about 400 lines long. We've been stacking information on our system prompt over and over again as we've continued to get more business requirements. So our system prompt is very long. We'll take a look at that. We are then going to take some time to evaluate the tools that we're using. Right now, as I mentioned, we have 12 different tools. 3 of them are actually kind of wrapped sub-agents. So we'll take a look to see what we can do to make that more efficient. And then lastly, if there are any sub-agents that we really need to make our agent effective, we're going to take a look at the best way to actually construct sub-agents with Claude managed agents. I'm going to jump back just for a moment. There's one thing that I forgot to mention for you as you get started. Within the repo folder, there's 2 different folders that you'll see. There's a before folder, and then there's a starter folder. Those contain 2 separate agents. So if you want to view the messages API version of the agent, again, this is just me building my own agent loop and my own agent harness around the Anthropic messages API to invoke Claude. You'll see that within the before folder. If you want to view what that agent looks like when deployed on Claude managed agents, you can look in the starter folder, which exists right below that. If you want to deploy your agent on Claude managed agents, you can run uv run deploy starter. So again, run your evals using the messages API version, -- agent before. You can then deploy your agent on Claude managed agents. We already have it built for you, and it's really easy to use Claude Code to kind of compare the 2 and understand exactly what's going on and what some of the differences are with Claude managed agents. Okay, so I'm going to jump over here, and we're just going to open up Claude Code, and we are going to build together. I'm going to zoom in very far so that you can see everything and so that I can see everything. And we'll just talk through exactly what happens when I run some of these evals. And we'll talk through the process that we usually go through to do what I just called hill climbing on the evals themselves. Okay, so if you're looking at Claude Code here, again, I just used Claude Code to actually run my evals because I want Claude's help in triaging what's going on. So this is me. I'm using Claude Code. I have Opus 4.7 running, as you can see on the screen. My effort level is set to extra high. I usually set effort as extra high with Opus 4.7, and I forget about it. That's the effort level that I usually stay on. We find that it gets great performance with extra high effort altogether. Now, you can see on the screen, the first thing that I did was I ran my evals. So I used the bash capability in Claude Code, and I ran uv run evals -- agent before. Claude actually went ahead and ran my evals. So I'm going to scroll down, and we're going to look at what Claude found while actually running those. So you can see the response that we got, the results that we got from this eval run was actually lower than what I told you before. So we ran them and we got 62%, which is worse than the 83% that we started with. So we passed 7 out of 12 of them. And it looks like Claude has provided us with a diagnosis for the different evals that we actually failed. Let's scroll down just a bit more. And we are going to use Claude to understand a little bit more about why this actually happened. So you can see here, I am using Claude to provide me some of the themes around why we actually failed some of these evals. Again, this is a great technique. If you have evals for your agent, again, as Giri showed before this session, you can use Claude to actually go about triaging these. So it looks like there's a few different themes that Claude is figuring out based on this agent. So the first thing, Claude is seeing that our model is taking on a lot of work that it should have tools in order to do. So our model is doing a lot of reasoning across information that it just doesn't have the tools to be able to complete. It looks like there is some issues that we have with the enforcement of output structure. So our model and our subagents are producing information in a particular output structure that doesn't align exactly with what we're looking for with to pull the best performance from our agent. If I continue to scroll down here, you can see there were some policy issues, et cetera. As I mentioned before, we have a system prompt that's really long right now. And so Claude is seeing some confusions based on the information that's found within the system prompt. So again, you can see Claude has found some root causes. Now, we're going to do a few different things here. Again, we're going to go one by one and address some of the areas that we're seeing issues on within our agent. So I'm going to scroll down here, and we are going to use Claude Code to triage some things within our agent. Okay, so the first thing that I'm going to ask Claude to do, we're going to talk through this. Claude is making some changes, which is great. System prompts tend to get very, very long when we accumulate agents over time. So the first prompt that I ran, if you're following along, feel free to go ahead and do this. I encouraged Claude to look at my agent.py file, which is where our main CMA agent loop is located. Again, that's agent.py. And I essentially said, hey, Claude, do you have any thoughts on the system prompt? Maybe I can use skills instead of a long-running system prompt for progressive disclosure. So the first thing that we'll talk about is skills. There's been a few other sessions on skills. The short definition that I like to use is that skills are packaged and composable information that Claude has the ability to pull into context whenever Claude realizes that it needs that information to complete a particular task. Right? Skills are really useful with Claude Code. Like if you need to provide Claude information on your testing process, or if you want to package up your brand and your UI components and bundle them into a skill that Claude can pull into context whenever needed, skills are fantastic. Skills are also useful within the agents that you're building for your customers. So if you're building a product and you are going to give that product to customers, you're building an agent, skills are great within that. In the case of the agent that we have on the screen here, again, we have a lot of different policies and a lot of procedures that go into our inventory management system. As I accumulated requirements over time, instead of building skills, I decided to take all of that information and keep appending it to my system prompt. So my system prompt got longer and longer and longer over time. This is not something that we recommend you do based on the introduction of skills, right? Leave the system prompt only for the information that Claude needs in its mind, regardless of the task that you give it. Skills are fantastic for packaging information that Claude is going to need some of the time, not all of the time, right? So if I ask Claude to go build a forecast, Claude is going to go ahead and do that. Let's see, I lost my computer just for a second. There we go. If I ask Claude to go ahead and build a forecast, right, Claude is not going to need forecasting information unless I specifically ask it to go ahead and build that forecast, right? So in the case of that particular task, I want Claude to pull forecasting information into its context window. Skills are also fantastic for making sure that you are being efficient with context, because if you stuff all of this information into the system prompt, you're polluting that context window with information that Claude does not need in order to complete a particular task. So again, the first thing that I did, I'll zoom in just a bit more so that you can see this, and I'll scroll up just a bit. I said, hey, Claude, can you help me take a look through my system prompt? Can I use skills instead? My system prompt is too long and I need some help. And so Claude did an analysis of this and realized that I have some pre-built skills that I can use to supplement information in my system prompt. So the first correction or fix that we're going to make to modernize our architecture here is we are actually going to remove much of the system prompt, and we're going to put that information into skills. And so you can see here the first thing that we're doing with Claude is we are activating a number of different skills that previously were not there before, and we're actually swapping our system prompt to be a short prompt instead of a long one. So if you're curious, if you feel like you have a long system prompt within the agents that you're building, feel free to take a look at this to see the differences between what was like a 400-line system prompt compared to about a 50-line system prompt. We've supplemented that, and we've switched a lot of that information to skills. Great. I am now going to continue working with Claude. So you can see we made those changes here, which is fantastic. There's some evals that I can go rerun. I'm going to ask Claude to do one more thing, and then we're gonna rerun some of our evals to see where we've improved. So I mentioned before that we have 12 different tools. You saw those on the screen in the second slide that I shared. As a part of this inventory management agent, we have tools that we've created for everything. So whenever Claude needs to retrieve data, we have a tool. Whenever Claude needs to analyze data, we have a tool for that. We have tools for everything. So I'm going to ask Claude to take a look at the tools that my agent has and help me think through how I can optimize here. So right now, Claude is running an analysis across the different tools that I have for my agent, and we're going to get to see what some of the results for. Now, while this is working, I'll give you a tip when it comes to building agents that we carry with us at Anthropic for our agents internally and the agents built with customers. Whenever we build agents, we lean into the same primitives that we as humans have access to. So imagine yourself when you show up to work, right? You have a computer that's sitting in front of you. You have the ability to navigate files on a file system. You can type in the browser and you can search the web. If you're an engineer, you have the ability to write and execute code. When you think about Claude Code as an agent, we've effectively given Claude access to all of the same primitives that you and I have access to when we show up to work every single day. Like Claude Code is a great coding agent because Claude is really good at code. But essentially what we've done with Claude Code is we've just given Claude access to a computer, right? And this is really powerful because this allows us to drop in better versions of Claude as we continue to release new models. And Claude just uses those primitives better than it did before. Right? Like imagine yourself after this conference compared to yourself when you walked in. You're going to have the same tools at your fingertips, but theoretically, your brain's going to be a little bit bigger. You're going to be smarter based on what you learned here, and you're going to be more effective while using the same tools. Claude works the same exact way, right? And so whenever we build agents, we lean into human-like primitives first. These primitives are things like code execution, and the navigation of a file system, the keeping of a to-do list, the ability to search the web. These are foundational tools that we always start with when we build agents, and we remove them as needed. An example that I like to give is with like document analysis. If you're building an agent that requires document analysis, maybe you have a lot of CSVs or Excel sheets that your agent is going to be looking over. Code execution, so the ability to write and run code, is one of the best ways of doing data analysis and working across lots of documents, right? Like if you need Claude to look across the CSV, giving Claude a bash tool so that Claude can write a quick Python script and reason across the results after running that Python script is much more effective than just uploading the entire CSV into Claude's context window, right? So again, we lean into these computer-like primitives first when building an agent. So if I scroll down here, that's exactly what we did here. You can see we took a lot of steps and we actually removed most of the tools that exist within our agent, and we replaced them with some of the primitives that I talked through previously. This is an inventory management agent that leans really well to this. I have the ability to consolidate and remove a lot of the tools that I'm using to reason across Excels and reason across forecasting data and just give Claude access to the same tools that Claude Code has in order to do that. What's cool about this is that when you build using Claude managed agents, these tools are actually included by default. So if you want to give Claude access to those same tools that Claude Code has and use them to drive powerful capability within your agent, you don't have to worry about writing a tool that gives Claude the ability to write and run code. Or you don't have to write a tool that gives Claude the ability to use the file system. You can just rely on those built-in tools that we have built ourselves for Claude Code that we just make available through Claude Managed Agents. I'm going to ask Claude to rerun an eval. The evals to see if we are getting better. Now, with your agent, there's always going to be the need to add some custom tools as well. Like you're only going to get so far by giving your agent the same tools that we give Claude Code. So we always start with those primitives like code execution and web search and to-do lists, etc. We always start there. And then we either remove those tools as we don't need them, right? There might be some agents where we just don't need web search, so we'll go ahead and remove that tool. And then we'll add custom tools whenever we need them, right? So again, when you think about tools, I encourage you to start with those Claude Code primitives, those human-like primitives, and then add custom tools only as you need them. In the case of this specific inventory agent, we were able to remove most of the tools and replace them with Claude Code. So you can see right now, Claude is redeploying my agent to Claude Managed Agents. So again, I have my agent locally. I am redeploying it based on some of the changes that we've made. And now I can rerun some of my evals to see the results. So you can see in that last command, I'm rerunning the F1 eval, and we're going to see what happens as a result. Now, we always get a lot of questions when it comes to MCP. So in the case of CMA here, you have a couple different options when it comes to tools. You can first lean on those Claude Code primitives, things like web search and code execution and file system. Again, that's what we start with. You can then create just custom tools, so standalone tools that only your agent has the ability to use. Then you can connect your agent to MCP. We see a lot of folks run towards MCP first, and a lot of our customers end up in this ecosystem where there's a lot of kind of chaotic MCP servers that exist. A lot of times they have overlap, which can create some problems. So when we build agents, again, we start with those Claude Code tools. We then create local tools only for our agent. We don't run to MCP. And then only in the case where we have a common collection of tools that multiple clients will benefit from accessing, do we go about the process of collecting those and publishing them as an MCP server. So only when we have multiple agents, maybe multiple Claude Code clients that need to access the same set of standardized and governed tools, we run towards MCP. Something else that's becoming increasingly common throughout the industry is leaning on Claude's ability to effectively use code execution as a means of executing tools. So we see a lot of capabilities coming out around just giving Claude access to use CLIs and invoke APIs using code and actually run tools using code instead of MCP. One of the drawbacks of MCP is that it does cause some context issues just in terms of polluting context and taking up a lot of space. So there may be some cases where you can just rely on code execution, either through CLIs or just by giving Claude the ability to invoke APIs using code as a means of creating more flexibility for your agent where you do not have to use MCP. So just something to keep in mind as you're building. Great. Okay, so Claude just got done. Looks like we have the before and after from some of the changes that we've made. And I think that this is pretty compelling, right? The first thing that jumps off the screen to me is the token usage. So before I was using over 200,000 tokens for a particular task. After leaning in on some of those file system primitives, you can see that that went down dramatically. This is a direct result of giving my agent code execution. So again, imagine instead of giving my agent a full CSV that needs to be read into context, I just give my agent the ability to write and run Python as a means of kind of navigating across all of that information. The agent uses a lot less tokens when it can write code and then run code and then read the results, instead of having to consume all of that data in Claude's mind and then use all of that kind of collective brain power to then make decisions based on the results. A few other things. We can see that our costs went down as well because we're just not using as many tokens, which makes sense. Our execution time went down as well. So this was a pretty good case where I think we got better overall, but this is not something that will happen all the time, right? We might see some cases where we regress, but this was the case where using some of those primitives as opposed to some of our more stagnant tools was clearly the right decision. Great. Okay, we're going to jump back and we're going to talk about subagents for just a bit. I'm going to copy another prompt to Claude, and we are going to investigate subagents. Now, I mentioned before that we had 12 different tools. 3 of them were effectively wrapping subagents. So if I'm Claude, I have the ability to call on a tool. That tool is a wrapper for a subagent. I can then go and invoke that subagent. See, Claude's doing a lot here. I'll scroll up just a bit and then we'll talk through it. The 2 main use cases the 2 main instances where we see subagents initially as being really effective is first when you want to throw a lot of Claude at a problem, right? So let's say that you're trying to do deep research or like web search. Let's say that you're trying to do, in the case of Claude Code, code-based exploration. That's a great case where like having many different minds running at the same problem makes sense. So subagents are a great way to parallelize and throw a lot of Claude at a problem to get it done faster and more effectively. The second case where it's really common to use subagents is when you need a fresh mind to look at a problem. So I'll use the Claude Code example first. I'll use my example as a developer. If I am writing code, I do not want to be the same person that is writing and also reviewing my code. I'm going to have somebody else review my code. So in the case of Claude Code, it makes a lot of sense to have one instance of Claude doing the writing of the code, and then another instance of Claude coming over the top and reviewing that. That does not have context about the initial instance of Claude. This is a great case for a subagent. Using just a code review subagent and layering it over the top is a great way to do this. We also have a subagent within our agent here, our inventory management agent, that we've actually kept as the result of some of the changes that we've made, and that's for forecasting specifically. So again, I have a forecasting capability that's within my inventory management agent. I do want to keep my forecasting separate from my main instance of Claude. I don't want anything in my initial context window to distort the forecasting process. I do have a skill that kind of walks through the step-by-step sequence and the guidelines that I prefer Claude use when writing and building forecasts. But again, I don't want the same Claude that my customer is talking with to also be the Claude that writes the forecast, right? So I want to divide that. So I'm leaning on that second example of when to use a subagent as the place where we'd like to go about doing this. So in this case, we've removed our other subagents and we've just replaced them with primitive tools, but we are going to leave the forecasting subagent. Now, we're not going to expose our subagent as a tool. Using Claude managed agents, there's a native capability for subagents that allows the logging and the observability of your subagents to be really effective. One of the problems with subagents is that when you have multiple instances of Claude running, first off, it's difficult to make sure that the communication between your orchestrators and your subagents is accurate and is seamless, right? There's a lot that can get lost in translation. Just like when I'm talking to one of my colleagues, I might be thinking something, they might be interpreting it completely differently. The same thing happens with orchestrators and subagents. The other thing that can happen is logging is really difficult in some cases, right? Because then you have to worry about collecting the transcripts from multiple different agents. So within Claude Managed Agents, we've added this native subagent capability. I saw it on here. Let me scroll up just a bit. I think Claude found it. Yes. So there's this callable agents capability that exists within Claude Managed Agents, which is essentially just like managed subagents, so that within your session information, you have observability and metrics about what exactly your subagents are doing that is as accurate as your initial orchestrator, right? This is, again, meant to solve one of the common problems of just having a lot of information that is hard to track with subagents. Well, we just did some building. Again, I'm going to skip through these because we spent some time talking about them. We just talked about subagents. Again, there's a few different cases where you can use them. We just talked about callable agents. You can also just define your subagent as a tool, which is what we did previously, but we actually moved away from that and we decided to use the CMA native capability. There are a lot of cases where you can just now scrap the subagent entirely and just give more flexibility and capability to your main agent. So what we have a lot of customers doing is actually just consuming capability into their main, in this case, orchestrator, because frontier models have gotten intelligent enough to manage across more information where you just don't need as many subagents. So again, when you're thinking subagent, I have a big problem that I want to throw a lot of Claude at, or I want a separate Claude to kind of look at the work of either me or of a different instance of Claude. Two great times to use subagents. Okay, so let's look at the architecture that we ended with. Again, refreshing us, we started with an orchestrator, system prompt of about 400 lines long. We had 12 tools, 3 of them were subagents. What did we end with after this exercise? We still have an orchestrator, but we deployed that on Claude Managed Agents because I didn't want to have to worry about infrastructure, scaling, security, etc. I just wanted to worry about my agent. Right? Like in Will's simple terms, like that is when I reach for Claude Managed Agents because I just want to worry about building the best thing possible and not all the messiness that comes with it. We simplified our tools. We now have, right now 3 different tools. So we actually simplified everything to just use bash, read, and write. Now, when our agent starts executing, we sync some data into the Claude Managed Agents environment so that it can reason across that data. We actually simplified our system prompt to 15 lines long, and we replaced all of our business logic with skills. So again, I was just stuffing requirement after requirement into my system prompt. I decided to take that, package it up as skill so that Claude could pull that information into its brain only when Claude realized that it needed it in order to solve a problem. As a result of this, we showed how we can then start hill climbing on evals to see improvements over time. So at the end of this, my eval score is about 92%. I've simplified my design. I'm leaning into some of the primitives that make Claude great. And I'm seeing the positive results after doing so. Again, some of the eval results, you see that here after running this. We're getting faster. We're using fewer tokens because we're leaning into code execution. Our turn count is remaining sort of the same, but again, because the token usage and the cost is going down, I'm actually okay with Claude taking more turns. There are some cases where we'll see the latency not drop maybe as much as you would expect, but for some of these more sophisticated high intelligence agents where like forecasting is at play, I'm willing to take a little bit higher latency at the expense of seeing my performance improve and my costs go down. All right, let's wrap with some takeaways here in our last minute. When we build agents, we start with a single agent loop that is equipped with very simple primitives that give Claude some of these human-like capabilities, like the ability to use the file system, like the one that you have on your computer, web search, code execution, Sometimes a to-do list, again, we start there and then we build accordingly. The next thing that we did is we used progressive disclosure through skills. Instead of stuffing our system prompt with a lot of information, we made information accessible to Claude whenever Claude realized that it needed that information in order to solve a problem. This is great because we can run more efficiently, and we're not polluting our context window, and we're giving Claude more flexibility to make decisions. The last thing that I want you to walk away with, right, evals in general, this idea of hill climbing is a concept that we lean on really heavily at Anthropic, right? You have evals, you establish a baseline, you then tweak your architecture and you rerun evals and you get better over time. Now, as a result, it's important to make sure that your evals are updated as your product capability expands. Always make sure that your evals are encompassing the things that you care about and that you're measuring within your agent so that you can actually make sure that your agent is accomplishing the thing that you set out to accomplish. With that, folks, we're going to go ahead and wrap. I really appreciate your time today. I'll be in the back after the session, just outside of this room, in case you have any questions at all. Thank you.
Welcome all. Thank you for joining the workshop. We have a pretty full house here today. I'm very pleased to see that. Quick show of hands. Who here loves Claude Code? Okay, yeah. You're in the right place. Yeah. Lovely to meet you all. My name is Arno. I'm a member of the Applied AI team. I'm an architect there. I'm here today to tell you how we Claude Code at Anthropic. Do a workshop, and you can code along. You'll get some credits. I think there'll be a QR code in just a moment, so make sure to grab that. There'll be people floating around that might support you. So if you have technical difficulties, we can help you out. Anybody here in this room who hasn't used Claude Code before? Okay, great, good, because this is, there's more to do. There's more to find out. I'm happy you're here. Let's get started. So let me get my clicker. Yes, excellent, yes. Please grab the QR code, set yourselves up. There'll be a repo here as well that you can clone. There are 3 phases in it we're going to work through. There's an interesting verification setup that you can work through alongside me, and it's quite detailed, so you probably will want to investigate it a bit later yourselves. What we're covering today is based on this version of the talk that Tarek gave in San Francisco just about a week and a half ago. Who here follows Tarek on Twitter? Fantastic, great, yeah. So he published that as a blog post called The Unreasonable Effectiveness of HTML Files. And he's basically pitching that moving on from Markdown files, we're going to be using HTML instead. And we're showing some of that today. Like I said, there's a repo to go along. Enjoy that along the way and later on in the week as well. Where are we now? Where's this all going? I think everybody probably notices that agents are becoming more and more capable. Why is that happening? That's happening because the models are becoming more and more capable. And so if the models become more capable, it means agents can run for longer and you can give them more and more complex tasks. But that also means that we have to change our way of working. We have to change our habits. That's part of what today is about. How can you change the way that you're working with Claude Code to get more out of it? If you're going to let your agent run for a longer period of time, then you can burn through a lot of tokens if it does the wrong thing. And you want to avoid that ideally at the beginning. And so that's where the idea came from, to push more and front load more of the verification that the human would do in the spec into an HTML file because it's a more rich and more human ergonomic way of engaging with the content that your agent is going to be building for you. And we'll see how that works. There are a bunch of things around agents that are worth reading. We have a lot of engineering blogs on our webpage. We also have the standard blogs. You should check all of those out. There'll be a lot of information there. There's a lot of interesting information about harnesses, about long-running agents. All of these things are important. Today, we'll focus on 3 levels. And there'll be something a bit more basic, something a bit more next level, and then something that's quite interesting, and that'll be a bit more in depth. The first thing is, the more capable the models get, the more you should try to resist constraining them. Who here, by the way, has heard of The Bitter Lesson by Richard Sutton? Great, fantastic, this is great. So I'll for those who haven't raised their hands, Richard Sutton is basically the father of reinforcement learning. If you're reading a book about reinforcement learning, it's probably authored by him. And his idea was basically that you could spend all your time trying to, with your human capabilities, hard code up front and constrain the system, but in the end, pouring more data and more compute at it ends up getting more capability than anything that you could have come up with. And there's a similar analogy here, right? The models are becoming more and more capable, and so you should accept that the model is probably better at extracting requirements from you than you are at defining your requirements. The requirements are latent within you, just like when you talk to your users. Your users, they have an idea of, they know it when they see it, but they're often not very good at articulating what they need. And likewise, you probably know what you want when you see it, but Claude is likely better at extracting what you want and what you need from you than you are in specifying it to Claude. That's another direction to take this in. So we'll talk about that, removing ambiguity, letting Claude prompt you and interview you in prompting. Then how to then understand and plan. We used to do this all with Markdown files. We still do it with Markdown files. A colleague of mine once said, the Markdown file is the lingua franca of the AI native software development lifecycle. I thought it was pretty poetic. But it seems like that format is a bit constrained. It's getting too long. There's a lot of lines of Markdown file to read. We can condense more information into HTML files, and that's what we're going to do today. And then how to verify. Not test, actually, but just to verify in this context. How to make verification native to the thing itself so that the agent can drive it alongside a human, or eventually not, headlessly as well. That's where this is all going as well, right? The agents are going to be doing more and more of this natively. And how can you set the artifacts that you produce up to natively be testable and verifiable in the way that you need? So we'll do an example. By the way, has everybody had a chance to grab that QR code and set themselves up? Very good. There'll be a link to the repo eventually as well. I think that comes in a bit. Let's say we want to do a build splitting app. Very simple. You go out with friends, you want to find out who owes what. Yeah. Let's let Claude interview us around doing this. So in this case, I'm actually going to, before I do that, give you an example of how you would do this and how you could do this better. Yeah? What's good prompting, what's bad prompting? Bad prompting is when you say, just make it better. And a lot of people that I watch using Claude Code just type, make it better. Make no mistakes. Yeah. That's not good prompting. You want to encourage Claude to extract from you specific details. So give the domains. Don't overspecify the outcome, but specify the areas that you are interested in. Right? That's what makes this good prompt on the side different and better. Focusing on the audience, for example, or suggesting an open-ended way to answer the question, as opposed to predefining it up front. And then that will prompt Claude to iteratively interview you. All right, so I've got a Claude open here, 2 different Claudes. Who here has used fast mode? Okay, not that many people use fast mode. That's why I set it up here. And who here uses auto mode? Oh, I'm very happy that you all use auto mode. You need to be using auto mode. If you're not using auto mode, you need to be using auto mode. It makes it so much easier. Use auto mode. Good. Who here is setting their effort parameter? Good, good. Our recommendation is X high, but you can also set max effort. I mean, in my case, I think I kept it at X high for this. So just to touch on how those look, right? Like we've got /effort, which is the effort parameter, /fast, which is the fast mode, which is I've turned it on. And then we have the auto mode, which we cycle into like this, Shift Tab. Yeah, auto mode is the best. So I'll copy paste my. You all, when you have the repo, will see one of these prompts is in there. So I'll just copy paste the prompt in here on the bill splitting app. So okay, Claude's going to ask me. You tab through these, right? Like you'll tab through these like this. And in my case, I want to just for friends. And I want it, is there a secondary audience? No, no secondary audience, and we'll leave that as that. The key thing here in the prompt is that you want to prompt Claude to use the ask user question tool that you saw me use in the prompt earlier before. Let me submit those answers, and then it'll write that spec, right? So you saw me in my prompt explicitly referring to the ask user question tool. That's what triggers this workflow. And depending on how well you specify that prompt, you'll get better outcomes. So it'll generate a spec. We could then turn that into a bunch of different ways of building the app. It's going to take a while, so we'll go back to my slides. Could I go back to the slides, please? Great. So let's say we have a plan. It generates a plan. We've answered some questions. It's getting better at extracting turn by turn from me what I actually want without me having to upfront verbalize everything myself. Then I want to be able to check, is it what I want? Well, an HTML file is more dense, much more information dense, much more ergonomic for you to understand what the thing is going to look like. You can even use a screenshot with it. You could use the Playwright MCP later on for that as well, right? You can interact with it much more richly than you could with a very long Markdown file. And especially if the Markdown files get, if they get more than about 200 lines long, it's unlikely you're going to read it, and certainly unlikely that your colleagues are going to read them. Before we started here, I had Claude with Opus 4.7 generate a few examples for me of what this could look like with my bill splitting app. And we'll look at those now. We have them here. The prompt I used is in the repo that you'll have access to. I asked Claude, give me a few different directions, 4 different design directions, explore them, generate them as HTML, and let me explore them across each other. And it came up with these different ones. So one sort of brutalist, one Tokyo, fintech. We'll click them all one by one. So this is what this one would look like. And then this one might look like this. Completely different aesthetic, right? And I click around. And this is much better for me to give feedback to Claude on than it would be to just try to infer from a Markdown file what the thing is going to look like. I could go in and, like I said, take screenshots, feed them back into Claude. Who here regularly takes screenshots to give information to Claude? Very good. You should be doing that. That's very good. Especially when you're doing front end, it's really hard to articulate, like, the thing is slightly off, or there's a misalignment here, and it's like, you'll find that you run into the limits of what you can express, and it's actually easier for, especially Opus 4.7, which has a much better vision model than before, to extract from you what the problem is, and proactively. Great. So, a few examples. Tarek has a lot more in his repo, which you will find in the repo as well, online. So far, we've covered letting Claude extract information from you interactively as an interviewer, because the longer you let an agent run, the more important it is that the spec is comprehensive, the less likely it is that you will be able to upfront define everything, and it's better for you to iterate with Claude in that manner. Then, what's a better and more efficient and ergonomic form factor? It would be the HTML file. And now, the more important part from all of this is how to verify what Claude has done and how to make it agent native. And that's what we're going to cover with the repo. I think we have, I think there'll be one slide where you'll get to see the actual slides to engage with, the actual URL to engage with. So what you want to do is make it part of the artifact. And that's what we're going to cover today. In fact, there's part of what we're doing today is we're going to use storybook, fixtures, a testing library, sort of data emissions and attributes, and Playwright MCP for a React app, with components that you will have seen before, but remixed in a way to make it easy for Claude as an agent to extract the data contracts in the DOM and then run verification and then even record the verification, which is how the Claude code team that Tarek is on runs this, and that's what the demo that he built refers to, right? Like, it'll be a generation of verification steps that get run through, that get a recording, and that's then put on S3 or shared somewhere else with colleagues, and that's how you turn these verification steps into something that is generated by the agents, and then that you have fewer and fewer touch points with. That's something that you can replicate, especially from that repo. The way to do that is to sort of sensibly modularize, but that becomes really clear when we look at the actual thing. So I encourage you to go to that link. There'll be a repo. This is the repo under CWC workshops, Claude with Code workshops. And there's the one for today's session, which is how we Claude code. What's covered in there is phase one, which we just covered, right? The simple prompt to say, hey, I'm writing a bill splitting app, interrogate me on the requirements so that I don't have to miss any in my upfront description to Claude. The second one is generating 4 different HTML design directions that we could explore for me to then feed back on or for me to decide. And then thirdly, we have a verification framework here. And it's in a different context. It's not to do with the bill splitting app. It's regarding a to-do app, a small to-do app written in React. And we're going to show how we built verification entirely into that along the way. That's described in detail in the README for phase 3, and then also in the verification detail as well, which is here. So if you want the deep dive on how this is set up, you can read this, and it's all provided in the repo. It's pretty cool. What is it focused on? We've written a small to-doist app here. I can add an item, test. It's hard to see. There we go. Very good. And then I could tick it off and drop it as well. And I could clear the finished items. And so many things are happening here in terms of the state, and we'd like to verify that it's all working alongside the tests that are already defined. But these verification steps, we'd like them to be driven by an agent. There are 3 ways that we're going to do this. So we're going to do this in a human-readable way. But then that same way of doing it in a human-readable dashboard, we're going to verify in an agent-first way and let Claude do that separately. And then there's a separate way in the repo as well. You can just run verify, and then it'll just run the test matrix there. You'll get a slightly different result if you do it from the repo versus here, but the principle is the same. So human-readable, agent-driven if you're doing it from Claude Code or somewhere else, and then also just generally headless like you might do it in CI. We'll have a look at it in a bit more depth. We'll go here into the app, and we'll actually look at, there we go. We'll look at elements. We have here the actual emitting, so the emitting different data aspects, the data verify unit, the total done and active. The component itself here is publishing its state to the DOM. And so if I change my state here, I might add test again. See that updates, and then I drop it, it updates again. So this is what the agent can read later, as opposed to having to scrape the DOM. You can just, if you publish the state here separately from the React internals, you'd be able to run the verification independently of whatever the state of the app is. And that's how this is set up to work. And then you can run this further down the line as well. Each one of them gets this, right? If you look at, if I pull up the That's a bit hard to read. Let's do that here. Every component gets one of these, right? There'll be schemas, there'll be fixtures, the known states, and then the invariants. There are particular ones here that always have to hold. You'll test them with probes, and we'll do one example, which we've hard-coded. We've hard-coded an example that will fail the verification, and we'll let the human-verified dashboard catch it, but then we'll also let the agentic way of doing it cache it as well, and we can let Claude Code find it and diagnose it for us. So that same approach also works here. So I've got the dashboard defined here, and what we see here is, there we go. Like I said, we've got the different schemas, the invariants that we've defined, and we can run these, right? Individually, we can see how they would execute here. Got an example here. Or also, I could run all of them. In fact, I'm going to do that now. I run them all. One of them triggers artificially because we planted it before. We're going to scroll down and find out what that is. And it's here. We will actually look at how we can replicate this for an agent as well. And we would do that like this. Go here. Inspect. And we could run basically the manifest of all the different verification steps that are defined here as state in the DOM. We can get them in the same way that we have them here. We expand that. It's getting a little bit small. As an example like that. And then like that as well. Great. If we do that, then we can also actually run them just specifically here. I'll do it manually first. Let me replay them all. Close that. In this case, we're running this, not to perform the verification, but to provide the evidence of the verification. We can later on record this. We can record these as clips, which would just be videos that we capture. And then we would store them, share them with colleagues, put them on S3 or whatever it might be. Let me pause that here. There we go. So here's our summary. We have one that's deliberately failed. I'll explain that in a second. But in each case, you can also see the details of how this was done. The key thing here is that we want to, it's important to include the probes to push off the happy path. And then a lot of this will be generated by Claude for Claude, right? So there's a way of scaling this further. In the end, we'll go to the one that didn't work. So the one where we hard-coded that the sums don't match. In this case, the state doesn't match. 3 plus 4 does not equal 10 in this case. And we'll get the same result if we run verify all from the Claude here as well. And we'll let Claude do that in a moment as well. There we go. Then it's a little bit hard to see that there's pass, and fail. So there we go. Okay, good. We can change this, right? The point here is that I'm trying to show that the idea is to let something agent native be read as the DOM contract here. That's what we established earlier, that the state is managed here, or well, not managed, but at least viewable to an agent that it can then run the verification end to end itself. And we can let Claude do that afterwards as well. In this case, we can also make a change that will break more. Let me see if I can break the chain. I'll break the contract, but not the app. And I'll do that here. So I could change, for example, here. Under to do app, total stats, I'll delete that. I'll undo that afterwards as well. And if we now rerun, then all of these ones at the bottom here will fail. And we'll get the same when we run this again from here as well. Oops. There we go. All of these are failing, not because we broke the app, but because we broke the contract. That Claude can then natively verify. Excellent, great. I want Claude to tell me what's going on with these ones. At least, well, not the ones that I broke, but I'll undo the ones that I broke. But I'd like it to tell me what's going on with this one. And so let me correct the change that I made before. Control Z, autosave, rerun, and there we go. So we've done it manually, and we've shown how we can match what the agent would see versus what we would do. But we can let Claude run this headlessly itself as well. So I'll do that, and I'll pull that open. Just let it run. This one's broken deliberately, and the rest works. Great. So we have Claude running here. I mentioned fast mode before. I mentioned auto mode, which is great. I mentioned /goal. In this case, what we're going to do is let Opus 4.7 help us find out why that particular verification failed. I've already connected the Playwright MCP for this. And it's going to use that. And it's going to run. Schema got rejected. 4 + 3 does not equal 10. Yes. If you were to run bun verify, then you would actually pass the tests in this case because we've deliberately put the verification in wrong just to demonstrate that then the test matrix itself will actually pass. But the idea here is to separate out what you could do as a human versus then what you could do via an agent directly from the browser using basically the commands that you saw, and then also what you could run headlessly directly from the CLI. If you wanted to do it like this as well, then you could record the outcome that we talked about. Yes. So here, in this particular setup, you've actually got the ability to show how you would record these. The same delayed running that we've shown, you could run and record as evidence, basically to show that it would work, and then you could store that. And they could run like that. This is very common right now. The Claude code team records basically all the code changes that they do like this, all the front-end changes at least. especially at the pace of the shipping that we have at the moment. Are people able to pull up the repo and get the verification setup working? Yeah, very good, very good. Yes, you can store them. I mean, like you can just put them in S3 or whatever, or share them with colleagues. Or in our case, we have a version. We have an internal. This is more automated than what I'm showing here. In our case, we do record them. Not certain for how long or in what context, but it's part of a regular cadence. And then you get the. In fact, you get the. I should have triggered that. Did I not see that? There we go. So you have each clip. You could download all of them or download them individually, and then that's basically the bundle that proves the verification worked. So I guess to bring it around to what we've covered so far and where it's going. 3 different surfaces: the human surface, right? And then the agent first from the browser, mapping on the same way. And then you could also run it in CI with just run verify. The objective here at the end is to figure out how do you embed the verification into the artifact itself. There's more detail. I encourage you to check out the repo itself and actually run a few examples yourself and run a few tests. Right? You can change the code, see what breaks, rerun it yourselves. It's quite detailed, and it's what Tarek and team use in the Claude Code team for their work already. This came pretty quickly, just a week and a half ago into this demo. So I encourage you to check this out. What's new really is the remixing and the new arrangement of primitives that you're already familiar with, that you're already using, just to make it available to be agent first. That concludes really.
Everyone, thank you for being here today. I'm pretty much excited to have this session with you. I know we are almost at the end of the event, so thank you for bearing with us. So just to start, let me introduce myself. I'm Ivan Nardini. I'm a developer advocate at Google Cloud, working on building content in partnership with Anthropic. And in order to start this presentation today, I just want to ask a very simple question. So how many of you in the last week used any AI tool to code or build application? Okay, the majority. How many of you use the same AI tool to build and deploy application on Google Cloud? Yeah, just a few of them. So the goal here today is just try to make it better. So in this demo, what I'm going to show you is how you can use Claude on Google Cloud to build and deploy application end-to-end. And in order to do that, I'm going to wear 5 different hats. And we will start from, imagine the use case, right? Imagine the scenario. You are in an enterprise context. In an enterprise context, you probably have a team like the one that we are visualizing here that it's engaged to build a new feature or a new product. So starting from the left, you probably have a PM. Some of you in this room are PMs. And the PM might have an idea of how to improve a particular product or how to implement a feature. And starting from this idea, he shared this idea with a UI UX design, which allows him to design the idea, to visualize the idea. And after the idea starts getting a shape, then the idea is sent to a software engineer that essentially starts developing the core logic behind this idea in order to ship and make the application accessible or the feature accessible to everyone. And but before to ship it, in order to be confident on what you are releasing, you probably have to pass a security review. So that's why you have a role like the security engineer that will allow you to be confident in the release. And finally, once the application gets released, you probably have a data persona, like a growth marketer or a data analyst, that analyze the data that are collected through the app in order to generate insight and produce feedback to the PM in a way that the product or the feature itself gets improved. So these are kind of all the personas that in a simple way we can imagine are involved in the software development lifecycle. Now, with respect to these personas, Claude Code, the Anthropic's coding agent, augment all of them, providing several components that we are going to use today. So as I said, for the remaining part of this presentation, I'm going to put the hat of all these personas. I'm going to show you how you can use these Claude Code components together with Claude on Google Cloud in order to build and ship a very simple feedback application that at the end of the presentation we are going to use to rate my performance here. But before to start building, of course, you need to set up the Claude Code that we are going to use. And I'm so excited and so proud that we worked together with Anthropic to make this process of setting up Claude Code in order to use model on Google Cloud in a very simple way, in a very straightforward way. So you have multiple methods to use Claude models on Google Cloud in Claude Code, but the simplest one, the faster one, is using the application default credential, which automatically finds your credential, for example, the user one, and based on the environment that you're going to use. And as you can see in this representation, so recently, Claude Code also introduced this wizard that will simply allows you to detect your project and your region where the models are served, and check which models are available in your project, and let you to pin them in order to start building your application. At this point, probably you're familiar with this, and you're wondering, okay, but what is different to use just Claude Code with Claude models? Why using Claude on GCP, on Google Cloud? So there are many reasons why you want to do this. So first of all, because you pay for what you use. So the usage of Claude models on Google Cloud is per token, so you don't receive a message cap. And also, if you're building enterprise application that needs to go to production, you can always access to what is called provisioning throughput, which essentially will reserve some throughput for you in order to build this kind of application. The other important reason why you want to consider Claude on Google Cloud is, as I said, the setup is pretty straightforward using the ADC. You don't have an API to rotate or environment variable to set in some sense. So it's a happy journey in